Unit 2A, Lesson 4. In this lesson, we're going to graph systems of linear inequalities. So just like we did in the previous lesson, we're going to graph a linear inequality. Then we're going to graph another one on the same coordinate plane. The region we're going to shade is the overlap of both of those inequalities. In this first example, we want to graph the linear inequality system. So we have y is less than 2x plus 4, y is greater than or equal to negative 1/2 x plus 2. We're going to graph both these inequalities, find where those solutions overlap. So first I'm going to graph y is less than 2x plus 4, plot the y-intercept, which is 4, slope is 2, construct some points. Now I need to determine whether the line is solid or dotted. It's strictly less than, so I'm going to construct a dotted line. So I constructed the dotted line through the points, then I had to pick a test point to determine which side of this line I'm going to shade. I picked the origin because the graph does not go through the origin. Plug 0 in for x and y and simplify. I get 0 is less than 4, which is a true statement. Okay, so that means I would shade to the region where that ordered pair, the origin, occurs. But this time, rather than shade that region, I'm just going to construct two arrows showing which direction I'm going to shade. I don't want to shade that whole region right now because I still have to graph the other inequality, and my solution, shaded region, in the end is not going to be all of these points. Okay, so I'm just gonna, so there's not so much of a mess later on, just construct these arrows showing which direction we need to shade later on. Now we're going to move on to y is greater than or equal to negative 1/2 x plus 2. I'm going to plot some points. My line this time is going to be solid because in my inequality symbol there's an equal to sign. So first I plotted my y-intercept, which was 2. Used my slope, which is down 1 over 2, to plot some other points. Constructed a solid line through those points. Now I use the origin as my test point to determine which side I'm going to shade. When I plug 0, 0 in for x and y and simplify, we get 0 is greater than or equal to 2, which is a false statement. So if 0 is below my blue solid line, that means I have to shade the opposite region. So I would need to shade above this blue solid line. Okay, so now we have both of our inequalities graphed on the same coordinate plane. We're looking for the solutions that are overlapped, that satisfy both of these inequalities. So anything that is going to be to the right and below our green dotted line, but also above this blue line. So we can see that overlap is going to be this upper right region. Any point, any ordered pair in this region would satisfy this system of inequalities, meaning it would satisfy our first inequality, give us a statement that's true, and satisfy the second inequality, give us a statement that's true. So this is the region we want to shade. Just a quick recap of this process. Graph each inequality on the same coordinate plane like we did in the previous lesson, except do not shade the regions right away. Use arrows to indicate which direction we could shade. That's going to make it easier to determine the final shaded region, the solution to this system. Now to a second example, same process. We want to go through and graph this system of linear inequalities. We have 2x plus y is less than or equal to negative 6, and then we have y is less than negative x minus 4. For this first one, I am going to choose to use the cover-up method to graph this linear inequality. So if I find first my x-intercept, that's going to be negative 3. I would take negative 6 divided by 2. My x-intercept is negative 3. Now if I cover up my x term and just solve for y, my y-intercept is going to be negative 6. Now my graph, or my line that I construct through these two intercepts, is going to be solid because my linear inequality has an equal to sign. So I can construct a solid line through those 2 points. Once I have my solid line constructed, I have to pick a test point. Again, I'm going to use the origin because my graph, my line does not go through the origin. When I plug 0, 0 in for x and y, I get 0 is less than or equal to negative 6, which is a false statement. So if the origin is above and to the right of this line, I got a false statement. I have to shade the opposite region. So I'm going to construct two arrows indicating which way I have to shade in the end. Now I need to go through and graph the second linear inequality. We have y is less than negative x minus 4. I'm going to plot my y-intercept, which is negative 4, and then use my slope, which is negative 1. So I go down 1 over 1, construct quite a few points here to get a good view of what my graph is going to look like. Now it is strictly less than, so the line I construct is going to be dotted. So once I have my dotted line constructed through my points, now I plug in an ordered pair for my test point. I'm going to use the origin again. Plug in 0 for x and y. Simplify, we get 0 is less than negative 4, which is a false statement. So I shade the opposite region. So I need to shade below and to the left of my blue dotted line we just constructed. Now to shade the final region, I have to find the overlap of both graphs, which looking is going to be the region contained by the upper portion of our blue dotted line and the lower portion of our green solid line. So when graphing systems of linear inequalities, graph each inequality like you normally would, just save the shading portion to the end using arrows to indicate which way you should shade. The final shaded region has to satisfy both inequalities.